Hello, this is Reem from Exam Hub. Today I'll be solving Physics Paper 2 AS Level Structured Questions 9702 Variant 3 May-June 2019. Question number 1, Part A1, define resistance. So resistance is potential difference divided by current. Part 2, a potential difference of 0.6 volt is applied across a resistor of resistance 4 gigaohms. Calculate the current in picoamperes in the resistor. For this, you must first convert 4 gigaohms to just ohms. So this becomes 4 into 10 to the power 9 ohms. Now the formula is current is equals to potential difference divided by resistance. So current is equal to, our potential difference is 0.6 divided by 4 into 10 to the power 9. This gives us the value of current as 1.5 into 10 to the power negative 10 amperes. Now you need to multiply that to 10 to the power of 12 to convert this amperes to picoamperes, and you get the value. Part B, the energy E transferred when charge Q moves through an electrical component is given by the equation E is equals to Q into V, where V is the potential difference across the component. Use the equation to determine the SI base units of potential difference. So potential difference is equals to energy transferred divided by the charge Q, where energy is equals to force into distance, and force is equals to mass into acceleration. So energy is equals to mass into acceleration into distance, and charge Q is equals to current into time E is equals to, the unit for mass is kilograms multiplied by the unit for acceleration is meters per second square, and the unit for distance is meters. Q is equals to, the unit for current is amperes into the unit for time is seconds. So kilograms into meters per second square into meters divided by ampere into second. This gives us V is equals to kilogram into meter square Question number 2, Part A. A resultant force F moves an object of mass m through distance s in a straight line. The force gives the object an acceleration a so that its speed changes from initial speed u to final speed v. Part 1. State an expression for the work done w by the force in terms of a, m, and s. So work done is equals to force into distance, and force is equals to mass into acceleration. So in short, work done is equals to mass into acceleration into the distance s. The distance s in terms of a, u, and v. So this is s is equals to, we'll be using the formula v square is equals to u square plus 2as, and we'll be rearranging the formula making s the subject of the formula. So this becomes v square minus u square divided by 2a. This is all in terms of a, u, and v. Part 2, use your answers in Part 1 to show that the kinetic energy of the object is given by kinetic energy is equals to half into mass into speed square. Explain your working. So the energy required to change the kinetic energy of the car from speed u to v is the work done by the force F. So I'll be writing this. Change in kinetic energy of the car is equals to work done by force F. Now change in kinetic energy is equals to work done by force F. Work done by force F is mass into acceleration into distance s. So mass into acceleration into distance s is we'll be taking distance as in terms of A, U, and V from part 2 over here. So S now becomes V square minus U square divided by 2A, and hence change in kinetic energy is equals to half into mass into speed square. Part B, a ball of mass 0.040 kilograms is projected into the air from horizontal ground as illustrated in figure 2.1. The ball is launched from a point X with a kinetic energy of 4.5 joules. At point Y, the ball has a speed of 9.5 meters per second. Air resistance is negligible. Part 1, for the movement of the ball from X to Y, draw a solid line on figure 2.1. To show the distance moved, label this line D. The displacement, label this line S. Okay. So the distance the ball travels combines both the horizontal and the vertical parts of its travel, but displacement will be just the shortest distance from the starting position, which is X, to the finishing point, which is Y. So the distance, which I'll be labeling D, is going to be the curved path from X to Y, labeling it D. This curved path basically shows that this journey has got horizontal plus vertical components. This curved part is the distance, and the displacement is going to be a straight line from X to Y, from the starting position to the finishing point. Part 2, by consideration of energy transfer, determine the height h of point Y above the ground. So when ball is at ground level over here at position X and is launched from here, it has kinetic energy of 4.5 joules. When it reaches this height h, it still has some kinetic energy left and must have gained gravitational potential energy due to the height h. So following the rule, which is that energy is always conserved, we'll write kinetic energy at X is equals to kinetic energy at Y plus gravitational potential energy at Y. Kinetic energy at X is 4.5 joules, which is mentioned in the question. Kinetic energy at Y can be calculated by using the formula of kinetic energy, half into mass. Mass is 0.04 into speed at Y is 9.5. So half into 0.04 into 9.5 square, which gives us 1.805 joules. Plus the GPE, the formula for gravitational potential energy is mass, which is 0.04, multiplied by 9.81, which is the acceleration, into height. Part 3. On figure 2.2, sketch the variation of the kinetic energy of the ball with its vertical height above the ground for the movement of the ball from X to Y. Numerical values are not required. So kinetic energy must decrease because gravitational potential energy is increasing along with increase in height. So at Y, its kinetic energy must be relatively lower than that at X. So I'll have a negative gradient with a straight line. My graph shouldn't be ending at 0 kinetic energy at height h, because at height h it says that kinetic energy is 1.805 joules. Question number 3. A cylindrical disc of mass 0.24 kilograms has a circular cross-sectional area A as shown in figure 3.1. The disc is on horizontal ground as shown in figure 3.2. A force X of magnitude 8.9 newtons acts on the disc in a direction of 30 degrees to the horizontal. The disc moves at a constant speed of 0.60 meters per second along the ground. Part A. Determine the rate of doing work on the disc by the force X. So rate of work done is power. So power is equals to force into velocity. So here we have got both these two quantities, force and velocity, but they are at angles. So we must first get the horizontal component of force X, means the horizontal component of force 8.9 newtons, which is going to be 8.9 into cos 30. So I'll write horizontal component of force X is equals to 8.9 into cos 30. Now when you get this, you will multiply that to speed 0.60 meters per second and you get 4.6 watts. Your force needs to be in the direction of your velocity. That's why we take the horizontal component of force X but not 8.9 newtons or the vertical component of force X. Part B, the force X and the weight of the disk exert a combined pressure on the ground of 3500 pascals. Calculate the cross-sectional area of the disk. So the formula is pressure is equals to force divided by area, and hence area is equals to force divided by pressure Our combined force for exerting pressure of 3500 pascals will be the vertical component of force X along with the weight. We shouldn't be taking just 8.9 newtons because that force has got two components and only its vertical component X downwards that contributes to exerted pressure, which is 3500 pascals. So the vertical component of force F is 8.9 into sine 30 plus one more force which acts downwards and contributes to the pressure of 3500 pascals is its weight, which is mass into 9.81, 0.24 into 9.81. Now this whole gets divided by the pressure, which is 3500 pascals, and this gives us the area as 1.9 into 10 to the power -3 meters square. Part C, Newton's third law describes how forces exist in pairs. One such pair of forces is the weight of the disk and another force y. State part 1, the direction of force y. So according to Newton's third law, both these forces are going to be in opposite directions to each other. Hence, this is going to be upwards since weight acts downwards. Part 2, the name of the body on which force y acts. So this is going to be the Earth or whichever planet it is on. Question number 4. Two vertical metal plates in a vacuum are separated by a distance of 0.12 meters. Figure 4.1 shows a side view of this arrangement. Each plate has a length of 2 meters. The potential difference between the plates is 900 volts. The electric field between the plates is uniform. A negatively charged sand particle is released from rest at point X, which is a horizontal distance of 0.080 meters from the top of the positively charged plate. The particle then travels in a straight line and collides with the positively charged plate at its lowest point Y, as illustrated in figure 4.1. Part A, describe the pattern of the field lines of force between the plates. So 2 marks, 2 points. The first point is going to be that field lines are going to be straight from more positive plate, or you could say positive plate which is plus 900 volts, to less positive plate which is 0 volts. Second point is that separation of field lines is equal since it's mentioned that the electric field strength at all points is uniform. Part B, state the names of the two forces acting on the particle as it moves from X to Y. So X to Y. First is the electric force. Due to the fact that this charged particle X is negatively charged and being attracted towards positive 900 volts. So the first force is electric force and the second force is discharged weight. Part C, by considering the vertical motion of the sent particle, show that the time taken for the particle to move from X to Y is 0.64 seconds. So they are talking about the time taken for the vertical component being covered. For this to be calculated, we have got initial speed of charge at x, which is 0 meters per second, since over here it says that it is released from rest at point x. The vertical distance from x to y is 2 meters, and g is equals to 9.81 meters per second square, which also is acceleration of free fall. We can use the formula s is equals to ut plus 1 by 2 at square. So s is equals to ut plus 1 by 2 at square. Since our initial speed is 0, so this ut cancels out, and the vertical distance being covered is 2 is equals to 0.5 into the acceleration has got a value of 9.81 into t square. Now t has a value of 0.64 seconds, and you also need to mention why you're not considering ut, because u has a value of 0. Part D, calculate the horizontal component of the acceleration of the particle. So again, for horizontal component, initial speed is 0, so u is equals to 0. The horizontal distance this sent particle is covering is 0.080 meters, so s is equals to 0.080 meters, and time taken is the same as that of vertical component, so t is equals to 0.64 seconds. Now we can use the same formula, s is equals to ut plus 1 by 2 at square. When you substitute all these values, you'll get a value of a as 0.39 meters per second square. E part 1, calculate the magnitude of the electric field strength. So electric field strength is equals to potential difference divided by the distance between the charged plates. Our potential difference is 900 volts divided by the distance between the charged plates. It's 0.12 meters. And this gives us the electric field strength as 7500 newtons per coulomb. Part 2, the sent particle has mass m and charge q. Use your answers in part D and E part 1 to determine the ratio q by m. Okay, so electric field strength is also equal to force divided by charge. Since force is equals to mass into acceleration, so now we'll substitute the values. Our electric field strength is 7500 newtons per coulomb. This is equal to, we'll be taking m multiplied by the acceleration. The acceleration has a value of 0.39, since in the question it has asked us to consider the answer for part D, so 0.39. Now this whole gets divided by the charge, which is q. Now you will be getting a ratio of mass divided by q as 19230.77. However, the question is asking us to find the ratio q by m, so we'll be taking the reciprocal of this value 19230.77. So this gives us the ratio of q by m as 5.2 into 10 to the power negative 5. F, another particle has a smaller magnitude of the ratio q by m than the sent particle. This particle is also released from point x. For the movement of this particle, state the effect, if any, of the decreased magnitude of the ratio on part 1, the vertical component of the acceleration. So smaller ratio means either its charge is smaller than the sent particle, or it is heavier than the sent particle. So vertical component of acceleration is always going to be due to particle x's weight, which doesn't change its value, and that is 9.81 irrespective of masses or charges. So this doesn't change. Part 2, the horizontal component of the acceleration. Horizontal component of acceleration will be decreasing in both cases, whether the particle gets heavier or carries less charge. Question number 5. A vertical tube of length 0.60 meters is opened at both ends as shown in figure 5.1. An incident sinusoidal sound wave of a single frequency travels up the tube. A stationary wave is then formed in the air column in the tube with antinodes A at both ends and a node N at the midpoint. Part A. Explain how the stationary wave is formed from the incident sound wave. So how are stationary sound waves formed? Incident wave reflects at the top of tube and they superpose with reflected waves. This is how stationary waves will be forming. Part B, on figure 5.2, sketch a graph to show the variation of the amplitude of the stationary wave with height h above the bottom of the tube. So this is going to be a sinusoidal graph. At h0 there is an antinode. At antinode the height will be maximum and half the distance of 0.6 is 0.3 at node. So at node 0.3, this is where the reflected ray and the incident ray will be joining, will be intersecting with each other. So there are two antinodes, and on both these antinodes the amplitude is going to be the maximum, and at node where the reflected and incident wave will be intersecting with each other, h will be 0.3 meters at this node, and hence amplitude will be 0 at this node. So at both ends h is equals to 0 and h is equals to 0.6 meters. There's going to be maximum points, and at h is equals to 0.3 there is going to be a minimum point. So this is going to somewhat look like this. The minimum should be at 0.3 because this is when a node forms, and a node forms when both these waves will be intersecting with each other. I'll show you the waves. Suppose this is the incident wave. And this is my reflected ray. So wherever these waves intersect with each other, that point will be called the node, and these two openings will be called antinodes. At point node the amplitude is going to be the minimum, or I should say 0, and at points antinodes the amplitude is going to be the maximum. Part C, for the stationary wave state the direction of the oscillations of an air particle at a height of 0.15 meters above the bottom of the tube. So at height 0.15 meters, it must be somewhere here. It's going to be along the tube. Part 2, the phase difference between the oscillations of a particle at a height of 0.1 meters and a particle at a height of 0.20 meters above the bottom of the tube. So there will be no phase difference between both these points. It's going to be 0 degrees, because the reason to it is that if you talk about particles on two different oscillations, means one particle on my incident wave and the other one on the reflected wave, then the phase difference between these two particles will be 180 degrees in stationary waves. Otherwise the phase difference will be 0. And you must know that particles which are on the same oscillations, they have a phase difference of 0. And why is the phase difference 180 degree for particles on two different oscillations in this stationary wave? Because you see that these two oscillations, they are this one is a complete mirror image of this one, or vice versa. Part D, the speed of a sound wave is 340 meters per second. Calculate the frequency of the sound wave. So frequency is equals to speed divided by wavelength. Our speed is 340 meters per second divided by the wavelength. Now the wavelength is what we have to calculate from the diagram. From this node to this antinode is basically forming 1/4 of wavelength. So we can write 1/4 of wavelength, and this covers a distance of half of 0.6, which is 0.3. So our wavelength is equals to 1.2 meters. Now we can divide here 340 by 1.2, and we get a value of frequency as 280 Hz. Part E, the frequency of the sound wave is gradually increased. Determine the frequency of the wave when a stationary wave is next formed. So our frequency is increasing means the next possible stationary wave is going to look like this. With 2 nodes and 3 antinodes. These two are nodes, and on top these are antinodes. This time our wavelength is going to be 0.6 meters itself, because this whole, again, the length of the tube is 0.6. This remains the same. The only thing which will be changing is the wavelength. Our wavelength this time is now much bigger than that in the previous part, because from one node to antinode is 1/4 of wavelength, and one node to the other node is half of wavelength. So half of wavelength and 1/4 and 1/4 over here. This makes one total wavelength. And now this distance whole is 0.6 meters. Now we know that our new wavelength is going to be 0.6 meters. So our new frequency is equals to 340 divided by 0.6 meters. This gives us the value as 570 Hz. Question number 6, define the ohm. So resistance is equal to potential difference divided by current. However, in this part, they are referring to the units. So 1 ohm is equals to 1 volt per ampere. Part B, a battery of electromotive force E and the internal resistance 1.5 ohms is connected to a network of resistors as shown in figure 6.1. Resistor X has a resistance of 8 ohms, resistor Y has a resistance of 2 ohms, resistor Z has a resistance of RZ. The current in X is 0.60 amperes and the current in Y is 1.8 amperes. Part 1, calculate the current in the battery. So current in parallel circuit splits into loops, which is 1.8 amperes and 0.6 amperes. So the total current, which is I, is going to be the sum of 1.8 and 0.60, which makes up 2.4 amperes. Resistance RZ. For this, we should know voltage in this loop, and we know that voltage in every loop is going to be the same since it's a parallel network. So let's calculate the voltage across resistor X. Voltage across resistor X is going to be equal to 0.6 into 8. This gives us the value of voltage across X as 4.8 volts. So now coming towards resistors Y and Z, they are going to have a combined PD of 4.8 volts, and current across this loop is 1.8 amperes. Hence combined resistance of this whole loop, means the loop which contains resistor Y and Z, is going to be 2.7 ohms. Thus that of resistor Z will be difference between 2.7 ohms and 2 ohms. So resistor RZ is 2.7 minus 2 volts. This gives us 0.67 ohms. E is going to be equal to lost volts due to battery's internal resistance plus PD across this network. So our PD across this network is equal to 4.8 volts plus the lost volts due to this internal resistance is going to be current across this internal resistance multiplied by the value of the internal resistor, which is 1.5. This gives us 8.4 volts. So EMF of the battery is 8.4 volts. Part 2. Resistors are X and Y are each made of wire. The two wires have the same length and are made of the same metal. Determine the ratio cross-sectional area of wire X by wire Y. So R is equals to resistivity of that metal multiplied by the length of the wire divided by the cross-sectional area of the wire. They both are of the same metal, means they share equal resistivity. So do lengths. So R is directly proportional to 1 by cross-sectional area. Now cross-sectional area of X is equals to 1 by 8, and that of Y is equals to 1 by 2. Now when you divide 1 by 8 by 1 by 2, you get a ratio of 1 by 4. Part 2. Average drift speed of free electrons in X divided by average drift speed of free electrons in Y. So current is equals to number density multiplied by the cross-sectional area into drift speed into electron charge. Now drift speed is equal to current divided by the cross-sectional area. Due to both resistors X and Y of being same metal type, both resistors will now have same number density N and will have the same electron charge, so we can ignore N and Q in our new formula. So now the speed of X, which I'll denote with Vx, is going to be equal to 0.6 divided by 1, since the cross-sectional area from part 1 of X we got is A1, and the speed of Y is going to be equal to 1.8, which is the current across resistor Y, divided by 4, which we again got from part 1, the cross-sectional area of wire Y. And when you divide Vx by Vy, you get a ratio of 1.3. Question number 7. A sample of a radioactive substance may decay by the emission of either alpha radiation or beta radiation and or gamma radiation. State the type of radiation. 1 in each case. That part A consists of leptons. So this is beta radiation. Contains quarks. So this is alpha radiation. This is all theory which you will be learning. Cannot be deflected by an electric field. This is gamma radiation. Because this doesn't carry any charge, so this remains undeflected throughout. Part D has a continuous range of energies rather than discrete values of energy. So this is beta radiation. So this concludes my today's paper. Thank you for watching.